Remember that the only constant thing in this world is change. And this holds true when we deal with the concept of motion. In grade 7 science, we learned that motion is a phenomenon in which the object changes its position over time. It is described in terms of distance and displacement, speed and velocity, and acceleration. But what makes an object move? That's right, force. Anytime you change the motion of an object, you use a force. Force is simply defined as the push or pull of an object with a specific magnitude and direction. But how does force affect the change in motion of an object? To answer this, then let's investigate the relationship between the amount of force applied and the mass of the object, the amount of change in the object's motion. The moment we open our eyes in the morning, we barely observe several objects at rest and in motion. An object may be acted upon by several forces, whether the object is at rest or in motion. An object may be pushed or pulled in different directions at the same time. For you to identify the forces which causes the changes in the motion of an object, it is important to determine all the forces acting on the object. Let's try these experiments. Place the card over the opening of the bottle. Place the coin in the middle of the card. Pick the card as quickly as possible. What happened to the coin? That's right! The coin fell inside the bottle. The coin maintained its state of rest, which led it to fall directly down the mouth of the bottle. Let's try another experiment. Place card A next to card B in each setup. Put one disc on the first setup and 5 discs on the second setup. Simultaneously push the bottom on the card A in each setup. What have you observed with the mass and acceleration? That's right. As the mass increases, the acceleration of the card decreases. Let's try another experiment. Attach the straw with the balloon in one end. Place it over the card. Blow air through the straw to inflate the balloon. Then we will release the inflation end of the balloon. What happened to the card when the balloon was released? That's right! The card moved opposite to the direction of the air released from the balloon. Now that we know the Newton's 3 laws of motion, let's now explain the ideas of each law. The first experiment showed the first law of motion, or the law of inertia. It states that the body at rest remain at rest, or if in motion, remain in motion at constant velocity unless acted upon by a net external force. All objects have the tendency to resist changes in their states of motion or keep doing what the objects are doing. However, changing a body's states of motion depends on its inertia. A more massive object, which has more inertia, is more difficult to move from rest, slow down, speed up, or change its direction, as compared to a less massive object which has less inertia. The second experiment described the second law of motion, or the law of acceleration. It states that the acceleration of an object is produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force and inversely proportional to the mass of the objects. The acceleration of an object depends upon two variables: the net force acting on the object, and the mass of the object. So the acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. As the net increases, so the object's acceleration also increases. So, if you push twice as hard, it accelerates twice as much. But there is a twist. Acceleration is inversely related to the mass of an object. In other words, if the object has larger mass, there is a small acceleration, while small mass moving object has larger or faster acceleration of moving objects. Mathematically, the law of acceleration can be described using the following formulas. Like any other quantity, forces unit is expressed in Newton or capital N. 1 Newton is defined as the amount of force required to given a 1 kilogram mass and acceleration of 1 meter per second, or 1 Newton, capital N, is equal to kilogram meter per second squared. It is also the acceleration of any object due to gravity. Finally, the last experiment is an example of the third law of motion, or the law of interaction. It states that for every action, there is always an equal but opposite reaction. According to this law, the action is always accompanied by a reaction force, and the two forces must always be equal and opposite. Newton's third law of motion tells us 4 characteristics of forces. First, forces always occur in pairs. Action and reaction forces. Second, action and reaction are equal in magnitude. Third, action and reaction are opposite in direction. And fourth, action and reaction act on different times. Now, let us apply what you have learned in this lesson. For learning task number 1, fill in the blanks the correct letters being described in each item. Write your answer in your notebook. For learning task number 2, use the given required explain solution answer or the GRESA method in solving the problem below. Show your solution. Write your answers in your notebook. Let's answer the first problem. What is the mass of the part with a constant net force of 200 Newton exerted to accelerate from rest to a velocity of 40 meters per second in 10 seconds? For learning task number 3, refer to the illustration shown in picture A and B. Answer the right question. Analyze the given activities below. Write the letter that best describe the effect of force in the object in each activity. Please do not forget to subscribe to our YouTube channel, Math Cycle. Like the videos and hit the bell button for updates. I hope you learned in today's lesson. In the next episode, we will be focusing on how a body responds to changes in motion. This is Dr. Green P. Fidelino, your science teacher. See you all next time!